Hello there, and welcome back to STEAM with Steve. Today we're going to go through a Year 11 Software Design and Development exam, where we get to see what the preliminary examination looks like for our HSC students. Now, I was challenged by my Year 11 students as to how do you actually do an exam, and I thought about this for a while, and this is my response. So hopefully you get to see some insights into how my brain thinks through when I do an exam, which might be able to transferable along to your own experience. So let's jump on in here. So to start, what we have is the exam, and before I do anything, you obviously write your name on any of the write your student name positions, and before I do any writing or reading, I grab that highlighter. So the highlighter is the most important part of this phase. So before I even do the exam, I'll be going through the whole exam with the highlighter and trying to work out what is the important bit. So read through the instructions, which are pretty generic. You should have seen these before, and just grab that highlighter. Now, what I'm looking for when I'm highlighting is any of these keywords that we've covered throughout the year. Okay, so computer program, which type of documentation, and I might spend 1-2 seconds quickly looking at them, trying to think about what it might be, and I might give it a little bit of signals. Notice that I haven't written anything on the actual exam paper yet. So then plagiarism, looking through, what does plagiarism mean? And then didn't really see anything there that stood out straight away, so I've moved on to the next one. One-dimensional array, went through, looked at some of the options, and I think the last one's the best one because it's got the same data type. Clock speed, since to megahertz, I'm thinking millions, so I'm looking for anything that's got a million in it, which the other ones didn't. An integer data type, so we're looking at that. So you would need to consider some of the examples. So I think when I come back to it, I'll write out the examples. Machine readable code, and then we've got a colleague involved in the development cycle, so checking off how you went. We then went on to the next section, so accumulator. So accumulator means the number system, so that should help with that bit. Which of the following is best shows the planned sequence events for a development cycle? So think of your project management tools. A coding error, which is test data is used, which a program is loaded into, 5 logical elements of computer system, and what's regarded as volatile memory, and then a memory of one integer, the data type for one integer, I think it was, divided by another one. The data type that has the values true or false, I do it straight to Boolean, so don't have to worry about that question too much. When developing a software program, a programmer creates a simplified example to the customer to give feedback. So there's an example. So this is one of the development cycle questions, looking for project completion, which software approach. So as soon as I see an example, I'm thinking agile or prototyping. That should help there. EBNF syntax of a variable name in programming. So it's got a variable, is a letter, and then a letter, and then a digit. So it's got the curly brackets, so that means it can have multiple letter than digits, and then square brackets, which means it's an optional programming one, optional symbol at the end. Probably didn't need to highlight all the terminating values, but just have it. Which are the suitability of the algorithm, and then we've got to repeat until our little loop down the bottom there. Which of the following matches an EBNF and a railroad diagram? That'll be fun coming back to it. And then here's some pseudocode. Now, whenever I get pseudocode questions, my go-to is to highlight all the variables inside of it. Because all the reserve words are in capitalized letters, it makes it a lot easier to see. So you'll see whenever I see a pseudocode question, I'm going through highlighting what I think is important in the sentence at the top, but then I'm going through and highlighting every single variable. Now that makes it just so much easier, which hopefully you'll see when we come back to those questions. So that looks like a subroutine program. We're checking to see if the guess is equal to the target and then the result equals true. So it's going to repeat until we get the right guess from typing in the age. And it's also going to have the count based on the numbers that we were looking for. Which of the following is the best algorithm? So answer the question. So if the number's larger, then it's going to be equal to it. So it looks like it's a overriding algorithm. Then this one here, we're going to go through again, looking at all the different variables. So we've got input days, so it looks like a mainline algorithm at the top there, and then a subroutine. So my brain's thinking probably at 40% here. I'm not thinking exactly how to answer it, but I'm just going through making sure I've got those key words. So this looks like a what type of category. So is it local or global? So global means that the variables are accessed everywhere, whereas local is just inside. And then this algorithm down here has been refined, so it's got fine and free days. If you see the two comparisons, by highlighting it, that should show it pretty clearly. So then this one here, we've got to determine what is the output. So we've got an input, so that looks like it's just a straight counter flowchart. So it's going to add on and print out as the numbers as they go. That looks like similarly, again, just a straight normal one. This one looks a little bit more complex, so I'll probably do a desk check with this one just to get my head around it. Using algorithm, the following question, again, going through, highlight all the the variables that are changeable. Okay, and then this one here looks like you're reading from a database or a data store with a whole heap of records. So you've got names, so you're going to go through and check that algorithm. Straight away there's errors, so when I come back to this, I know that that algorithm's got some errors in it. We need to start thinking about what goes wrong there. This one here was a straight, like a deck of cards. So you got the whole numbers from 1 to 52. You're going to write an algorithm to put the numbers into that, which seems pretty cookie cutter straightforward. And then the next one down here, there's an algorithm for the num, there's ram between and a second array. So it looks like it's going to be almost a shuffle one, because as soon as I see that random number, that's what I'm thinking. Fibonacci sequences, so that's a specific math problem. So numbers that go from 0, 1, 1. So you add the two numbers before it. If the first number was 0 and the second number was 1, and that's just a progression. So you're going to create an algorithm that prints that out. The second one looks a little bit more complex, but the trick with this is to go through and work out exactly what it is. So it's defining a system and then describing what the algorithm is going to do before you go off and actually code out in pseudocode what the algorithm is. So it looks like a signing card. If they come in early, there's a certain thing. If they come in late, what happens with that? Then we've got a 2D array question. Awesome. So straight away, I'm looking at that. I've done 2D array questions a lot in class, so hopefully these should make sense. These are usually probably more towards the back end of papers because they're a little bit trickier. So it looks like it's just a simple multiply algorithm, and then there's an error inside it, so you need to modify it. Then we've got some binary to decimal questions, so you should know the numbers 1, 2, 4, 8, 16, 32, and so on. Wherever there's a 1 inside of it, you add that on. If you're changing backwards, if you've got the numbers, you just take it away. And same with multiplying. Then you also need to describe the difference between Unicode and ASCII, which we'll get to. Then this one's the fetch execute cycle. As soon as I see something like this with a CPU diagram, so you've got your RAM on the right there, and you're going to be taking the RAM, putting it into the control unit. Then the ALU does an operation to it and puts it back in. So then you need to go through how the registers sort of work, what the buses look like. Then we've got reference to the fetch execute cycle. So I think we came up with fetch deadly eels safely. It was a little anagram that we made up. So make sure you remember the 4 different steps in that. Then there's just a document where you got to describe the features on the GUI. So you're talking about the drop down boxes, lists, radio buttons, all those things that we've covered before. So a computer has 20 cabins. Students assemble a new computer must form on the campsite. So you got a whole heap of kids. I think this was a data flow. It was a data flow diagram. So you're looking for who the actors inside of this, and then you're looking for what are the exact operations that need to happen. So I'm trying to think here automatically. What are the processes, which are the big circles, that need to go inside of this? Okay, so then there's the data flow diagram question. Then we've got up here, we've got to describe the agile approach. So when software development, then we've got a good old railroad. So I'm guessing you're going to change to EBNF. And then the last one is the copyright laws. So what does public domain mean, and compare and contrast public domain and freeware. So you got to compare and contrast. So look at the command words as we go. Now that took probably 8 minutes to go through that whole section. That is the best 8 minutes you'll be investing, because now I just have to go through and execute it. So when I read this one straight away, I'm looking at the computer paradigm for documentation. If I want to show how a feature works, that's an online tutorial. Troubleshooting guide is used when things go wrong. So online tutorial is there to help. Plagiarism, so when I'm reading through this, it's not the same as piracy. So piracy is when you do use code without permission, illegal copy of software, distributing the software illegally around, whereas plagiarism is when you use code that isn't your own from another source. A one-dimensional array is the structure. So when it comes from various data types, it can't be that. And it's not just a set of data, test data. So it's a data structure that's important, and it contains elements of the same type. So for example, it's all integers, or it's all strings, or it's all singles or floats. The next one, straight away, megahertz. There's only one thing, so it's 2,300 million electrical pulses per second. So that's the clock speed. So that's how much power is coming into the CPU. An integer data type. Now, if you ever do get stuck with this, write out some little small examples, and that can get your head around it. So sprinter's time usually is done like that. You could technically say that the seconds were stored as integers, but then that's a bit more of a complex data type. Whereas something like the woolly jumpers in stock, that is a clear integer. Okay, so that it's sometimes there'll be questions where it looks confusing, and that's not on purpose. It's just so that you can try and find the best answer. Programming code with text editor and a compiled and machine readable code. So if you write your Python code in a text editor and then machine readable code, the original one was the source code, which is what Python does. You ask a colleague to be involved in the development. You're evaluating the testing code. That's called peer checking. So you're getting them to look at your code and then getting them to have a read through it and see if it's all good. The accumulator, straight away, that's math. That's what I think when I hear the accumulator. So it's a result of the latest calculations, because it accumulates the results as it goes through that CPU. Which of the following is best used to show planned sequence of events? That's the Gantt chart. So that's some project management tools that we've covered before. Which is the coding error is test data used to detect. That would be a logic error. When a program is on a computer, it's open to load into the RAM. So that's the memory that gets stored. Number 12, the 5 logical elements of the computer system. As soon as I read data, that's not a logical element. That's something that gets used inside the system. So I just went on a data cancelling spree. So data was an A, B, and C. So that's why D. So when you do the logical elements, you can process, you can control the computer. There's outputs, there's inputs, and there's also storage that happens with the memory. Which of the following is regarded as volatile memory? So RAM, again, that's the same thing. So volatile means that it can change its state. A variable is stored as one integer divided by another. So I think I did 6 divided by 6, so that equals 1. But if you do 7 divided by 2, it gives you a real number or a floating point number. So it has to be C. Cool. And there we go. So data type that only values are true. Boolean, we just worked that one out before, so that's 15. When developing a software program, a programmer creates a simplified example of the program to show the customer to provide feedback. The programmer then extends the program and continues the process of consulting the customer until project completion. So that was a simplified example. So this is what we were talking about before. I was thinking prototype or agile. Agile isn't there, so I would just go with the prototyping option. So it can't be structured because it's going to go through it's going back and forward with the customer. Can't be end user because it's already something that exists, and it can't be rapid because, again, product already exists. So you're trying to get those examples back and forward to the customer to provide that feedback. EBNF, so it's got to go letter, digit, and then maybe a symbol, because the curly brackets means that you go through that pattern. So the first one, you have a letter, and then you can go letter digit, so that works. And then you got another letter digit and no symbol, which is fine. The next one, you couldn't do it because the third character was a letter. Second one you couldn't do because the second character was a letter, and the fourth one you couldn't do because as soon as you use a symbol, you can't have anything else afterwards. Number 18, which of the following would not be used as suitable for an algorithm? So when you're building an algorithm and you're testing it, you want to work out this is before you actually code it all up. So this is when you're sorting out the suitability of that algorithm that you've built. You can do peer checking, you can do desk checking, or structured walkthrough. You don't want to do runtime checking, right? So the runtime checking, you're looking at the actual physical nature of the algorithm. So you don't want to be having it run and then having all these errors coming out. Which of the following statements is true? So you got a repeat loop. So repeat is a post test. So repeat until this condition is true. So it's definitely a post test. So it's A or C. That's what your brain should be thinking. And then there's this option of unguarded and guarded. So unguarded means that there's no fixed way of finishing it. It's whatever's inside those brackets. Okay. Whereas guarded would be something like a for loop, where you know that it's going to be executed a certain amount of times. So when we say unguarded, it's when we have something like a while loop or a post test loop, which is a repeat until. Because what happens is the programmer can control what the true statement is when the program ends. Okay, so it's a little bit more machine level. An E, B, and F diagram with a railroad diagram. So we've got A, A, B. So this is wrong because it should have been A, B, A, B, A, B, A inside of curly brackets, because that's what's happening there each time that it goes around. So that can't be that one. This one, just follow the path like a train. So A works, and then you would see if B works. Yep. And then C works by itself, and then you can do C with the optional B. So that's probably the answer. Now, just to check and confirm, those have got the symbols switched around. So unterminating symbols are rectangles, so values that you can put in, whereas terminating values are in circles. Yes, circles, which means that it can be any of those values. Now this one is a little bit harder. So you got A, then you would have curly brackets, because you can have as many B's or C's inside. So you would literally have a B or a C, which comes through. So you can either have a B or C as many times as you want, and then there has to be an A at the end each time. So there's always an A guaranteed, and then curly brackets that, so that's why it's not that. So 20 was B. So the following algorithm has logic error. So it looks like a range one. So we've got greater than 25 and then greater than 80. So I'd write those core numbers down. So I'd go 25, then 80, and we're looking for the test data. So what I'm going to do here is we're going to put the percentages in above that. So the range outputs that the discount would be. So it looks like it's 10%. So if it's greater than 25%, but then less than 80%, that's going to be 20%. If it's going to be greater than 80, it's going to be 30%. So if it's in between the 25 and 80, it's 20. And then if it's less than 25, so the else at the end is 10%. So then we're going to be looking at the test data down the bottom there. And there's a whole heap of different options here. So because it goes from 25 to 80, straight away the numbers would have to be greater than 80, would need to be included. Okay, and then because we've got those fixed points, the 25 and 80 should be probably in that test data set, because they're sort of critical points inside of it. So D can't be there because it doesn't have anything above 35 or anything above 80. This one here could potentially have been inside of it, but it doesn't have any numbers that are above 80 to test that 30% output, so it can't be that. The next one down below it could potentially be that one because it's got the 24 and the 28, the 81 that are outside of it, but it doesn't really test the 25 and the 80, which seem to be core values. Okay, so because of that logic, I went with A instead. So 15, 100, both outside. You got the 25 and the 80, and you also have some data inside of it. Considering the following module age, calling the main line of the algorithm, you got number, target, you've got the count, the result, and then you're guessing the age. So every time the guess comes in, you add 1 to the guess, equals the target if that's true. If the count is greater than number, you'll have to exit, which is whatever the person has put in. So how many times that you're guessing. And yeah, basically they're going to be guessing that to get that targeted number. So when you look at this, count and the result, local variables, number, and target are all global variables. That's not correct. So count and result will only exist inside that subroutine. The module needs 2 values from the main line. So the main line receives 1 value from the module, which looks pretty good. So you got the number and target, which is the 2 variables, and then the return value is the result. So it's probably going to be B. Just checking off the other ones. So terminating condition loop cannot be tested because number has not been initialized. That's not true. Number was given in, so that's not even on the radar. And the repeat until structure is not appropriate for the module. That's not correct. So yeah, definitely B. Whoop, I messed that one up. Should be B. Sorry about that. Refer to the modules and then the variables. So that's what happened there. We've got the indexes. So we're looking here for the largest number. So if we go through this, the largest number there was this index here. And because it's the largest value, yeah, it's just searching for the largest number, because every time it finds something that's greater, it just replaces it. That's what that bit of code there does. This one here has two modules. So what I would be doing personally is writing down the two separate modules. Do I see that the B? Nah, I should have seen the B. Sorry about that, guys. So then using the information in this structure, you got input days, and then you got print, and then you got days is greater than 5 equals the owing. So basically this checks to see if you're outstanding owing inside of a library system. So which are the correct outputs, which now the table, so identifies the category of each variables. So because days and owing is defined in the library find, so because they're up there, that means they're global. So they can be accessed inside of any submodule, which they are. Okay, which means that they're global variables. So both of them are global, which means that. Now, if they only existed inside the calculate, that's what a local variable means. 25, if we look at that, it's got find and find days. So they've tried to make the modularity on this. So what that means is it means if you need to change the find, you just literally change it in one spot only. You don't have to go through the rest of the code. So that makes it a whole heap easier when you're maintaining it. So instead of worrying about the logic and where does it belong, you're just looking at the top for the variables and where they're initialized. And then you can just change them in one spot. And you don't have to go through all the code. So that's what that's been done. So it's making the maintainability easy because of that modularity that we've used. So for 25, that's A. Cool. So now into the algorithm. So this is a bit of the flow charts. So we've got a flow chart. I'm going to just follow it through. So I always start from the top and work through. This is just going to be a simple adding on. So we're going to have the count variable. We're going to add on 1. Then we're going to add on 1 again. So we have 2, 3, 4. And then when it gets to 5, we exit the system because 5 is not less than 5. And then that's it. So the output was 1, 2, 3, 4, and then 5. And then you're just writing the numbers. Don't put commas here because we need to make sure that it's what the actual output should look like. The next one, same thing again, so we're repeating. So we've got index, so index started at 0. We're then going to add 5 onto it, so then it's going to go 5, 5, 10, 15, 20, and then when 20 is greater than or equal to 20, it's going to exit. So because it's a post test, you actually won't print out the 20. So just follow the, literally just follow the sequence that you've written out there. So it's going to go 0, 5, 10, and then pop a 15 on the end there. Then the next one down here, yeah, so that's not going to work. So then the next one down here, we've got 0, 1, 30, 10. Now there's a lot more complex stuff here going on here, so I would recommend doing a desk check here, just to make your life a bit easier so you can see all the pieces inside the puzzle here. So I would start with total, then I would have number, then I would count. And because there's a print statement, we would then use the out statement on the end there. Okay, so to start, we've got the out. Then you would draw your 3 lines down. So you got the total, then you got your number, and then you got your count. So the total is pretty easy. That starts at 0. So this first row would be the initialization phase. Okay, so 0, 1, 30. And then I would go down to the next line when we get inside this loop. So we're checking to see if the count ever gets greater than 10. So print out the totals to start. So straight away, the total is 0, so that gets outputted. Number is equal to number plus 2, so that's going to equal 3. Total is equal to total plus the number, so we've got 0 plus 3. So 0 plus 3 now equals 3. And then the count is equal to count minus 3, the number. So we're going to go 30 minus the 3 and pop it on in there. So that's one iteration of the loop done and dusted. We're then going to go again. So count is 27 greater than 10. Yep, we're all good. So we're going to print out the total. So we're going to put a 3 in there. We're then going to go num is equal to num plus 2. So we're going to put a 5 down there. The total is equal to the total plus the number. So 3 plus 5 gives you the 8. And then count is equal to count minus the number. So 27 minus the 5 gives you 22. And then we get an 8 there. Awesome. So then the count's still greater than 10, so 22 is greater than 10, so we're all good. So we go again. So we got number, so we do 5 plus 2. Then we go total, so we go 8 plus the num, so 8 plus 7, which gives you 15. And then the count is equal to the count minus the num, so 22 minus 7, which gives you 15 as well. And we're all good. So we haven't ended yet, so we go back up to the count. We check to 15, so we go 15 is greater than 10, so we're all good. So we print out 15. We then go through the numbers. So we would then go num is equal to num plus 2, so we get 9. Then the total, so we go 15 plus the 9, which is going to give you what, 24? Okay, now the count is equal to whatever is currently in the count minus the number. So you're going to do 15, take away the 9, which then leaves you a 6. And then you go back up to the top. So count is 6 greater than 10? Absolutely not. So we failed, we exit, and we move on. So then the output will be then 0, 3, 8, and then 15 in that order. Hopefully that sort of makes sense for that bit. Yeah. And then I was just checking here because I think I got a little bit confused with the count, but yeah, no, we're all good. Awesome. Next one. Use the algorithm below to answer the following questions. You got count is equal to 1, count is less than 5, and you got these names. So we've got this array of 5 different names. Straight away, my brain's thinking, because it said down the bottom error, so count's less than 5 if initialized count is equal to 1. So that's going to be a little bit, it's not going to do all the 4 values. Sorry, 5 values, it's only going to do 4. So when we go through this, we're going to do a desk check. So we're going to write the things out again. So we're going to go count, we're going to go to the name, we're going to do the student variable. And because it's only going to have the first 4 values, I'm going to write the first 4 and then the output at the end. Right. Now this is interesting because there's 2 different phases here. There's the initialization, so creating, so it's storing the values, and then there's the actual modifying the values and printing it out. So that might help when I was writing this to define what the loops do. So I would say that there's 2 different phases that's happening here. I then labeled each of the variables, each of the names with the number. So I said this was 1, this was 2, this was 3, this was 4, this was 5. And 5 will never be hit, which might tie into the error that we're going to sort of deal with later. So student at count, so we're starting at 1, would be Ascot. And that's going to store into the first position of the student array. So that's why we put Ascot in there. So again, this is the first phase. We then go to the second one. So we got Kitman. And then where's that going to get stored? Okay, and I think this is where I sort of was trying to get my head around it a bit better. So I said this is the reading phase, and then this is the modifying or the printing phase. So we're just doing the reading phase in here. So we're going to do Ascot, we've got Kitman, and then pop Kitman into the second position of the array. Then the third one was Yogel. So we put 3, Yogel. Then the fourth one was Dodd. Into Dodd, and there's no outputs at the moment because there's no print statements. And when it gets to 5, it ends that loop. So the reading phase is done once it gets to 5 because it's greater. Then we run to the modifying phase. So I think I wrote the reading bit there, just to get my head around it. And now we're into the modifying bit down here. So count is equal to count minus 1. So straight away 5 then drops down to 4. And then it's going to print out, what was that, position 4? So it should print out a Dodd. Then we're going to go 3, because it's going to minus 1. So it's going to be a Yogel. And then it's going to go Kitman, then it's going to go Ascot. but then it's also going to get down to 0 because it's inside this post test. If it was in a pre-test, we'd be all good, but because it's in a post test, what's going to happen is you're actually going to get 0, and then there is no 0 position in this array. Okay, because we've made the index starting at 1 at the very beginning there. So what's going to happen is there's going to be a big error when it gets down to that last phase, because it's not going to be able to know what a 0 means. It's going to look up 0 and go, what? I'm not going to know. And it's going to have a fail. So using desk check, support your answer, describe the error in the program, and suggest how these could be fixed. So because some computer scientists like starting at 0, I'm personally one of those. You could have just changed the count is equal to 0, and then that would probably fix all the issues. That would be the fastest way. But then there's another way that you could do, where you go through, if for some reason you needed a count to start at 1 because there's particular IDs attached, so 1 is that, and so on, because that's what the programmer has done here, it's only going to insert 4 names in the array. So to fix that, you could just change the count to less than or equal to 5. So what happens here, if you want all the 5 values, and this might be a feature that the program had testing data and didn't want the 5th one, but if that was the case, all you need to do is change that 3rd line of code to while the count is less than or equal to 5. Right, so while the count's less than or equal to 5, that would solve that. The other one then, if you go down here, is the error. So if it's equal to 0, it's not going to work. So all you would need to do there is change the count is equal to 1, because that's in that position. But like I said, the fastest way in hindsight, after a bit of reflection on this one, is you just make count is equal to 0, and then that solves all the issues within inside of the code. But that's on the proviso that that 1 wasn't needed. So index is going to be equal to 1. It doesn't know what to do when it gets to 0, so it's going to freak out. So the easiest way that we can do this is you're going to go until count is equal to 1. Pardon me. So look at that line of code, and then all we're going to do is fix that up and go until count equals 1. Awesome. Next one, here we go, Fibonacci numbers. So Fibonacci, arrays. So with the arrays, this is like shuffling a deck of cards. So what we're going to be doing here is we've got numbers from 1 to 52, and we're just going to do a straight build an array algorithm, which we've done over and over before. So this is pretty simple. You begin, we're going to have the build array function, I think I called it, or build something, I can't remember off the top of my head. Yep, build array. So we're going to build this array. Now this array is going to, you could do a for loop here if you wanted. You could do a while loop, doesn't really matter. I think I've done a while loop just because it's a little bit more exotic and it gives me a bit more control if there was other things that I wanted to change. So we go index is equal to 1, so that gives you the first position. We're then going to go while. So while index is less than or equal to 52. So that then will iterate through until that index is equal to 52. So that's the condition that we're checking for inside this while loop. And then what we're going to do is we're looking for when does it end, so it's going to be less than or equal to 52. So that's the next bit. So then we're going to indent in again, and we're going to literally input into a number array, which has been told up here, which is why that I highlighted it. So the following array called num. So we're going to do num, and we use square brackets when we access the index or whatever's the contents inside that array. So we're going to go num square brackets at that index and check to see if that's equal to 52. If it is, we're just going to assign it, so not check. And then once we've assigned it, we need to increment the index to shuffle across, to move across the next one. So index is equal to index plus 1, which does that incrementing. We then end the while loop, and then we end the build array submodule. Cool. Notice any of the reserved words are in capital letters. We then go on to the next bit. So we're going to have this, and like I said before, because there's a RAM between, straight away I'm thinking there's a shuffle. Most of these papers use -1 to indicate that there's been a replacement. So what's happened here, it's starting, if there's a loop inside the loop, so it's going to build, it looks like it's going to build a new array. Where is it called? Where is it down the bottom? New num. Yep, so new num is the new array, and it's starting from the position 1. So what I did is I wrote out the numbers. So I went 1, 2, 3, 4, 5, blah, 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 up to 52. And I pretended what actually would happen. So index equals a random number between 1 and 52. So I chose 8, right? And then because that's not equal to -1 at the moment, that's okay. Then new num, so this new array, which was a blank array of boxes if you think of it, literally would then get 8 thrown into it. And then whatever was currently an 8 inside a num would then now become -1. That's what this line of code down here does, these two bits here. So then what happens is, if we go through again, it would then see the 8. Let's say the index, just by luck, got random between and then got 8 again. It would then see that would be -1, which would then mean that this loop would have to go again. Because if it looked at it and it's not equal to -1, it's all good. But if it's equal to -1, you got to keep finding the number. So keep cycling through that first array that we built at the top until it finds a value that's not equal to -1. Okay, so this is a shuffle function, and then it overrides it. So then it's going to go again. So it's going to go to the next one and then look at it and go, whoop, this isn't going to work. So this shuffle function takes an array of numbers from 1 to 52. It then takes a value out of the original array and puts it into the new array at the first position, then the second position, the third position. It's going to keep going all the way up to, let's say 36 was the last number. So everything else was -1 in all those boxes up the top here. And then 36 was the last value. This repeat until, and this is where a bit of inefficiency, it would keep going until it found that 36. And as soon as it found the 36, then it would take it out. And then you'd be left with all -1s in that top array, which means that all the values have been found. And then you would have this new array of all the shuffle things. So like I said, it's like a deck of cards, and it's shuffling all of them up. So it chooses a random number in the array. Like I said there with the 8, I think I wrote some more examples. So the next iteration, a 3 was chosen, and then 5. So the third position would be equal to 5. And then in the old array, in num, that it would now have a -1 inside of it. So by doing that, what happens is you'll have this brand new array of all these numbers. So you would have 8, 3, 5, 13, 28, 52, 51, 16, etc. And then each time that number was taken out of the old array, there would be a -1 placed inside of it. The other advice, there's 3 marks on offer here, so I would try and fill in all the lines. So any type of these writing sections, make sure that you use all the space. Don't just write it's a shuffle function. That's good, but now you need to actually justify how is it a shuffle function. So this is appended onto the current position k value, which is what this is. So the k constant is what's controlling the new index, whereas the index is controlling what was in the old array. Okay, that's why sometimes you might see values saved as I, so I means index, just so that you've seen that before. So the k, once it's not equal to -1, it can't be appended, and once that number is inserted, it's then removed from your old array. So the old array value then gets reset to -1. And then, yeah, basically you should have this new shuffled array. Now there's a bit of inefficiency here. Like I said, at the end, if there was 36 was the last value inside of this array, it would keep going through this repeat algorithm until it found 36. So each time there's what, a 1 in 52 chance that it's going to find 36. So you could be trapped there for a while, which shows a bit of inefficiency. So to make this a better algorithm, what you technically should do is remove the whole box, and either we call it popping. So you remove that element outside of the new array and then form a new array that's going to be shorter. Okay, if you wanted to describe a better way of doing this, but yeah, for this example, that's basically what needs to happen here. And then by the end, every single value in that first array would equal -1. And you see, by showing that understanding gives the marker a better understanding of showing what you understood. Even with this little bit of side working out here might help. The other thing as well, when you're doing this, make sure you write inside the lines. I was a little bit out there. Markers like it better because they need to see it inside that. Right, the Fibonacci numbers. So we've got 0, 1, 1, 2, 3, 4, 3, 3, 5, 8. So basically the way this works is the number is the adding of the two numbers before it. So 0 and 1 is the first two numbers. So then the third number is 0 plus 1, which gives us 1. The fourth number is then 1 plus 1, which equals 2. And then 3 is equal to 1 plus 2, 5 is equal to 2 plus 3, 8 is equal to 3 plus 5, 13 equals 5 plus 8, and so on. So we're going to create an algorithm for the first 100 Fibonacci numbers. And they've given you a structure. You just need to basically paint by numbers and fill it in. So I'm just doing like a little desk check here. So I'm going 0, 1, then I'm printing it out. So Fib A was equal to 0, Fib B is equal to 1. This just helps me get my head around it. And it's going to print that out. So I'm going to do an index here to control the while loop because it's unguarded. So we're going to go index. And this is the guard that we're manually putting into it. So I'm going to go index is equal to 3 because I'm doing the third position. Now this is up to you. You could have done index is equal to 2 if you want to start from 0, but it just depends. Sometimes you might use it. Most of these exam questions, the marking guide, just so that you're aware, considers that the first value is always 1, not 0. So my advice doing these HSC exams is try and use index is equal to 1 because it does make it a bit easier for the marker if it does match the marking scheme. So then we're going to go through and then we're going to check until index is less than or equal to 100. So we're going to go through the first 100 Fibonacci numbers and then we're going to go Fib C. So Fib C, so the current value that we want to check is equal to Fib A plus Fib B. And this is what we're going to print out each time. So we're going to print out the next number as we're sort of growing this out. So I think this was me just making sure that I got my head around how each number was built. So yep, I'm just checking the Fibonacci numbers, how they look. So Fib C is equal to Fib A plus Fib B. And then I'm going to print out Fib C because that's been created. And then Fib A now gets shuffled down. So Fib A now equals the value that Fib B previously had. And then Fib B now equals Fib C. And then that's going to increase each time. And then the index is equal to index plus 1. Okay. Or for the C# friends, index plus plus. Right, so secondary school, this one's a little bit trickier. So what I would suggest is try and work out a little binary tree of how this structure might look. So I would do the if statements and break it down and look at the key times. So if the students, you've got a swipe in and swipe out program, they've got their ID card at arrival and a school record of attendance to attach to a school database. If the student swipes in before 8:50, the student is recorded as present. If it's after, there's two different options. They're either marked in as being late and the time is recorded, or they're signing out as an early departure. So from there, there's two if statements. There's an if statement inside of the if statement. So if they're before 8:50, it's all good. They're just marked as present. And then if it's after, you have to mark in as late. And then also that there was an early departure and also the time stamp. So write an algorithm to demonstrate the logic of the sign in and the sign out. Okay, which should be pretty easy. So First step, anytime that you write any pseudocode, luckily you got examples before, you literally just write the begin. So we're going to do begins, I think I call it student swipe. And what we're going to look for in here is how does the if statements look, and what are the inputs that we need from the user as they're typing. So because this is a bit more of a complex question, we need to be thinking about what does the user need to know before they're typing in their appropriate responses. So we're going to begin student swipe, which looks at their ID cards. And what we're going to look for is we're going to look for how to read the card. So we're going to read the card as it comes in. And then if, what are we going to look for? If the time, so the current time that the computer has on its clock, if it's before 8:50 a.m., and see how we're putting a bit of contextualization here. So it doesn't say 8:50 a.m., but by doing that, it makes the person understand what you're trying to contextualize here for the end user. Then we want to record that the student was present. So we then want to take the card input. So we want to write, and then whatever the card said the student ID number was, we want to write that card value present into the student record. Okay, otherwise, so now we do else, and then this is the second branch down here. So if they're signing in late, but they're just getting they're signing in, there's a different option to if they're signing out. So this is where we need that user feedback to make a decision. Okay, now obviously this is more of a text-based coding structure because you don't have a UI and all that type of stuff, but if you can get the idea across, that's what what I would be looking for as a marker. So we need to print in, so print please choose the system right, so signing in or out. And then you're going to read what the user types in or clicks on the mouse. And this is where it's a little bit different. So read the choice. So they're going to give it a different choice. Now, if the choice is in, that means that they're signing in late. So you would then need to write to the student record that they were late and the time of arrival when they came through. So we need to write late, and then we write that to the student record. So we're going to write the time of arrival, or in hindsight, after thinking about this, you would put in the current time as a timestamp. But as long as you can communicate the general idea of what needs to happen. So time of arrival in quotation marks is fine as well. Personally, maybe current. If I was to do this again, I would do current time because we've already used it back up here when we checked to see if it was less than 8:50. Okay, and then we go else, which is just the direct other option. And then you would write early departure, because that's what had happened. And then again, this is where it's up to you if you want to use the timestamp, or if you wanted to go through in a different way, that's fine as well. So write early departure and then the timestamp. So the time of departure, and we need to write that to the student record. Another hint when you're doing these pseudocode questions, try to write them a bit narrower. So move it across as far as you can over to this side. So then you know that you're going to get the maximum space out of it. Then we end the if, and then we end the little submodule that we just did. Awesome. 2D arrays, here we go. So we're going to have something that stores the timetables of the numbers 1 to 6 into an array product, has a logical error. So you begin, row is equal to 1, while the row is less than 6. So straight away I see a problem there. Should be less than or equal to 6. For column is equal to 1 to 6. Product is equal to row. That's not going to work. So it should be row comma column is equal to row times column. And then next column. And then the problem with this is you'll be trapped in an infinite loop because there's no way of increasing the row inside that while loop. So those are the 3 errors I can see straight away. So when you modify this, you have a couple different options depending on where the marker comes from. So sometimes they might put line codes. They might go 10, 20, 30, 40, 50, 60, etc. And you would just go 55. So then they know it's between 50 and 60. Or this way, what I did is I ended up just writing the whole thing out again. If it's a huge amount of code, please just use the line numbers. For something like this, where it's less than probably the 10 lines of code, you're better off just writing it out so it's clear. So if you look at this, like we just talked about, rows less than 6, you're only going to go up to 5. So it's going to go 1, 2, 3, 4, 5, and then stop. So it's not going to include the 6. The product is equal to row comma column, and then row times column, and next column, and then the while loop as well doesn't, like I said, have any way of incrementing, so it's freaking out. Okay, so down here, modify the code so that it operates correctly. I just write it straight out. Okay, because there is no line code numbers, it's kind of implying that you need to rewrite the whole thing. So you would go begin, you would then go row is equal to 1, that was all good. And then here you go while row is less than or equal. Don't just write the less than equal in one symbol. Make sure you do it as true. So you go less than and then do the equal symbol 6. And then you would go 4. Column is equal to 1 to 6. And go product, bracket, row. Please use the same variables. I shorthanded there with column, so do column. So in col when I was writing it up the top here. So that's column is equal to row times the column. And then next column, so then that will go through that for loop. So that's basically doing the columns like this. And then each time it does a while loop, it goes down in the next row. So then we then need to, row is now equal to row plus 1, so that increments the row. And then we end the while. And then we end the loop. And that's that done and dusted. Awesome. Doing well. Next bit, so we've got some binary to decimal. So we've got this is when you need to remember the numbers 1, 2, 4, 8, 16, 32, 64, 128, 256. We've sort of talked about that at the very beginning of the year. So looking at that, and wherever there's a 1, just means that that's activated and it's on. So you have an 8 and a 4 in this case. So 8 plus 4 gives you 12. Next one's a little bit trickier. I think it went up to 32 from memory. Yeah, so you got 13, you got 16, you got 8, you got 4, you got everything except for a 2, right? So you'll just do that. Now the trick with this is to group tens. So if you do 32 plus 8, that gives you 40. And then if you do 16 plus 4, gives you 20. So you got 40 plus 20, which gives you 60, and then add on the 1. That's a little trick that you can do with this. Convert the following numbers into hexadecimal. So this is when you do groups of 4. So you're looking for 4 zeros and ones, and then looking at the decimal equivalent of that, and then changing that value into hexadecimal. So that's a little bit of the hack that we've covered with this. So if you've got 1010, that's equal to 10. And if we know hexadecimal, you hexadecimal all the values. So you're literally going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1D, 1D, 1F. So same case here. I've broken this one down into 3 groups of 4 binary numbers, which is basically the ones column, the tens column, the hundreds column, more or less. All right, And then I've just made up a little table here just to get my head around it. So the first 4 numbers, that would be the equivalent of 12 in decimal. The next 4 numbers would be the equivalent of 2 in decimal. And the last one, 11111, would be the same as 15 in decimal. So then I use that little table that I got down there. So 12 is the same as C, because it's A is 10, B is 11, 12 is C, and then 2, and then F on the end. Convert the following numbers from decimal into binary. You should show you working. So 79, I think that was. You would go to the highest binary number that's just below it. Sorry, it's 39. Sorry, my bad. So you would have 32 and 16. Now I'll do 39, take away 32, which leaves you with 7. So you can't take away 16, you can't take away 8, but then you can take away 4, you can take away 2, and you can take away 1. Now I just went a bit of a speed run here because I know 7 is 111 in binary. That's up. Basically just keep taking away until you're left with that. So basically 39 in decimal is the same as 1001111 in decimal. And see the little 2 at the end? That's the base notation we've talked about before. Same with this one. So this is a little bit trickier. Find the biggest number that's closest to it. So 216, 128 would be the biggest because 256 is too big. So you would take away that. You can then take away 64 away from it again. You then take away 32, no. And then you can take away 16, which you can. So you put the 16 in. As you 8. And then, yeah, basically you've taken all the values away. And then you're left with that, which leaves you with 1011111. Oh, sorry, 1101100 in base 2. Now this one we haven't quite covered yet, but it's more of a year 12 process, but I'm going to show you how you could do it with the skill set that you had now. So you could convert the numbers into decimal, right? And then convert it back. So first 101 is the same as 5, and then 1011 is the same as 11. So if we did that added together, it gives you 16, and then you should be able to do that into binary back. Okay, because 16 is the 1 in the 16's column. This one, timesing, again, we're not quite up to that yet. We will definitely be covering this next term. So 1110 times 101. Like I said, I converted that back. So the first bit is you get 14 times 5, which gives you 70. So converting that, I just went through the process we did before. So 64 gives you a 1, 70 take away 64 leaves you a 6. So then you can't take away 32, can't take away 16, can't take away 8, can take away 4, and then you can take away 2 and 1. Sorry, the 1 shouldn't be there. Should just be the 4 and the 2. So that's wrong, sorry. That should be a 0 there. Describe the purposes of ASCII and provide the reason is in the process of being replaced by Unicode with UTF-8 and UTF-16. So ASCII is used to store your characters, and communicate any of the issues that you had and communicate the codes. Right, so ASCII is the letters. It's usually only 7 or 8 bit, right? So it's the 0 to 255. ASCII originally was built for the internet, so when you're transferring codes or communication codes across a network, when it stores in 8 bits, or a byte, so it stores as 1 byte and transfers that across the network. purpose of ASCII only really stores in terms of characters more the European, so Latin characters. So it does the normal alphabet A, B, C, D, and it has the couple of characters with the accents inside of it included. But it doesn't allow for Greek or Chinese or Japanese or Hindu characters to be used inside of it, which is what Unicode does. So Unicode, UTF-8 and 16, they're larger character sets basically. So it includes all the ASCII characters, but then gives you this extended version. So what it does, it usually has 4 bytes. So UTF-8, you can have the 4-byte version of it, which then gives you 32 bits. So if you add 32 bits, that's 2 to the power of 32, which is more than satisfactory to support all the different character sets that are out there. There's actually a YouTube out there if you ever want to look up that shows you all the Unicode characters. I think it goes for about 40 minutes, including all the Chinese characters. Sanskrit is just, yeah, it's pretty impressive. So 2 to the power of 32, which represents all of the different, over a million different character sets that you can choose from. Yeah, that's pretty much what Unicode does. So ASCII is a subset. So those first original numbers are the same in Unicode, but then Unicode extends on it and gives you this depth and all these different options on top of it that you can choose from. Awesome. Next one, straight away, fetch execute cycle. That's what I see when I look at this. So parts of the CPU, you've got your control unit across here because you've got your program counter and decoder. You've got your RAM on the right hand side, and then down the bottom you've got your ALU, or arithmetic logic unit. So it's going to be going back around. That's the sort of fetch execute cycle that's happening there. And there's the little decode as well. So the number 1 is the control unit that controls where all the information is going back and forth between. Number 2 is then the arithmetic logic unit, or the ALU. And number 3 is then the RAM, or the random access memory, or the storage space. And then what happens is the information is taken out of RAM here. It's then put into this control unit, then works out where it is. Then it decodes that little bit of information that was given to it. The ALU then does the different result. The accumulator then spits it out and puts it back and stores it into RAM. So the registers, that's what all these guys are up here. So the registers are those memory addresses. This allows the temporary storage of those values. So it allows the temporary storage of those data as it moves around. So it moves around that CPU. And then that information comes into the register. Then it comes down here to the accumulator. And then it's stored back into the RAM. And then what happens with the registers, they're storing memory, right? So memory is stored as 0s and 1s. So inside the registers, there's smaller registers. Some machine languages, when you're typing it, literally types it in hex code, so it binds the 0s and 1s together into characters. But that's what a machine doesn't understand. So a machine doesn't understand hex code or even Python coding or C#. It only understands 0s and 1s. So that's what the register has inside of it. The buses is then the components that allow the connection. So it's a bus, so it transports the information across in between each of these things. It's usually a cable that has an enable wire attached to it that the control unit then basically allows the register to connect in between each other. So when you've heard of 64-bit, that means the 64 bus wide, or 32-bit means the bus was 32 bits wide. So then with reference to this Zap1 CPU to the fetch execute cycle, so I think we made up a joke in our class. We did the fetch deadly eels safely. I think was the thing that we came up with. Right, so the fetch cycle is where you pull the information from the accumulator that we saw before. This decode is for the deadly is when you take that instruction and you decode it, so you work out what the CPU has to do. And here we go. So fetch deadly eels. What did we do? Safely, I think we called it. Yep, safely. Right. So fetch deadly eels safely. If you look at the little anagram there, the first letter of each one is what you have to do. Okay. And then there's my dodgy little eel because I got bored. So the fetch cycle is where you're pulling the information out, decode, you look at the information in the control unit, you execute, you go off and actually make the code do what it needs to do, and it stores the information in the accumulator, and then the accumulator puts it back into RAM. Okay, so the fetch execute cycle describes exactly the process of that happening inside of a CPU cycle. So each time it's iterating through, it's going through that with its clock tick, and then every time it gets across, it then goes to the next one. So it's the process where it goes through and fetches. So the first step is it goes into the RAM or the storage and then pulls out the next. So the program counter will say go here in this control unit, and then it goes and finds the location of the information from the RAM. It then pulls that back and puts it into the control unit. So that's the fetching cycle. That's when you've taken the instruction from RAM and then put it into the control CPU. Now the reason why it's put into the CPU is it's a lot faster for it to solve inside of it, not then going back to the RAM each time. So it takes that instruction that's been given into the register and then put it into the control unit for it to start activating. The next bit then is the decoding. So it takes that instruction from that was given into RAM, it then looks at it and identifies what the actual instruction is telling it to do. So it might be adding, it might be multiplying, it might be dividing. There's a list of different instructions. This is what we talked about when we talked about opcodes and operands. So opcode would be add, and then the operand would be the two values that you would want to add together. Okay, which is a little bit more complex than what we need to cover at the moment. So the decode is where it takes that instruction, looks at it and goes, okay, what am I doing here? I'm doing the add operation. Okay, what does that involve? I might be doing the jump NZ function. What does that do? Okay, so it looks at the instruction, decodes it, and works out exactly what does it need to do. The next step in the cycle then is to actually execute it. So then it actually looks at that instruction and then does it. So it's been decoded, the CPU understands, yes, it's looked up its tables, this is what on our architecture this means. So then the instruction on a Mac compared to a Windows machine might be different. So then it goes off and actually tries to calculate it. So it looks at the calculations that were given, the opcode, so add, multiply, divide, and then the operand, so the two different values or three or whatever it is. And then it goes off and does the arithmetic logic unit. So the arithmetic logic unit will actually go off and execute this if it's something that needs to be incremented or decremented. And then it stores. So then the last bit, it takes the information that's inside the accumulator there, and then it pushes it straight into the code. So the result in the memory is then put in the register, and then that's then popped on in. Cool. So then the next bit is we want to go through how would you actually redesign this. So this is a real simple user input field. And if we read through it, it's time consuming, entering details in the text boxes, the space below, draw an annotated new registration web page that captures the information more efficiently. So straight away looking at that, there's a whole heap of different things inside of it. So I would be looking at the title. You could use a drop down box. The sex, you could use radio buttons because they're very clear. Preferred name, username, you can merge the first name and the last name to get together, so then it's a lot faster for it to process. The password, probably need to have two different password checks just to verify that the password was typed in correctly. For occupation and hobbies, you might want to have multiple options. You might want to have a drop-down box because there's a certain set of options that you're looking for from the person. And in the date of birth, you might want to look at the calendar options. So when you click on it, it comes up with a whole heap of different choices. Okay. So time consuming, having to enter details into a number of text boxes in the space below, draw and annotate. So when you annotate, you actually have to put little arrows on and describe what the features are. You can't just redraw it. Okay. So I've got the title. I've drawn another little box, I think, here, and then now I'm going to annotate it to say that it's going to be able to drop down. So drop down box, and you can have Mr., Mrs., etc. The surname, same thing. You can't really do anything specific with that. So that would have to be just a normal text box. So surname would just stay the same. Same with the first name. So first name would be the same. So sex, if you went back to the 80s, it would only be male or female. Now we're a bit more open-minded, so you need to put it in the other box. You can make that totally optional. So I would do male, female, other, and then make a little box that, to give that other option to sort of fill in and clarify on that if needed. Date of birth, like I said, I would use the calendar. So the calendar on the side there, so basically it drops down. I would also put it in a fixed format so it's clearer to the person when they're entering it. So in Australia we use date, month, year, year. It's the sort of standard, de facto standard. So even putting grey text behind the box just to give the user a bit of prompting that can automatically clear once they start typing something in, or having that drop down box on the side. So with the little calendar, you click on it and then automatically the little calendar pops up, allows them to select. So so far these are some structures that you can put in place just to make it a bit clearer for those users when they're coming in. And then I've done a cancel button as well. So the only way to get out of this would be to close the whole window down. So there's a cancel and a submit. And then if we go up the other side, we then have the occupation. Like I said, I'd make a drop down box, give them some structured versions. So it might come from a list with already some preloaded versions. So when they start typing, it automatically fills it in for them. Same with hobbies. You might make that a check drop-down box because you might want them to select multiple options. That's sort of up to, it depends on the language as well and the scope of what is actually required here. But for hobbies, you might make it a drop-down box, or you might just leave it as a normal text box. Because they're looking for things to reduce the time, I would recommend putting a drop-down box there just to show that you've heard the concern. So the trade-off here is it might not have all the hobbies, or might have them putting another box in again, but that's what I would be doing. So then the preferred username, because they've already filled in the surname and the first name, what you can do is once the focus has been removed from those boxes, it automatically overrides what the preferred name is if there's nothing inside of that. So you might have a structure where it looks to see if preferred username is currently empty, and you type something in surname, then you go to first name, and then automatically overrides it once the focus is removed from both. Then the password, you might have it automatically generate one. So you might have a Google automatic form which fills it in. So you might have those automatically filled in. And then I would do a second confirm. You would also might recommend the security structure. So you might need to have a capital letter and a symbol and at least 8 characters inside of that. So then it's very clear to the user when they're doing the registration what information needs to be done. Cool, that's done. Getting towards the end here. So we're looking at this one here, they're doing an IPO diagram. So input, process, output. So straight away I would draw a table with that. So I'd do input, then I would do the process, and then I would do the output at the end. And then what we're looking for here is we're doing a timetable. So we want to allow the user to choose the start station and the destination station. We want to then display information about the suitable train to arrive at the start station. And then we want to provide options to view a list of the stations on a chosen trip. So the input here, there's a couple we're thinking about, because we've got this train timetable of a whole heap of different information. We just want to narrow it down because it's only going to be on this mobile device. So we don't want to have a whole heap of information here and overloading the user. We want to just keep it as robust as possible down just to these 3 points. So when we're looking at it, we're looking at the user can select the start and then also the destination that they want to go to. They then can also view a list of all the different stations that they want to go to, because that's what it said here. So the user can choose the start station and the destination station, which is what this does. And then you want to display the suitable train arriving at the station. So then you want to have view list button. So when it clicks on that, it then spits out the list of all the different stations that are available. The process, they then can calculate the route. They can display the train arrival. They want to generate the route, the stations, and then you want the on route locations of the stations as it's going along the train. And then here you want to have a list of the trains and then a list of all the different stations that they can get to. That's pretty reasonable. So then the next bit here, campsite has 20 cabins with 10 beds, so there's straight away 200 beds inside the whole place. Students attending the campsite must form small groups between 2 and 10 students, sorry about the rockiness there, and are allocated to cabins to maintain groups being split. A computer program needs to be developed to allocate groups to different cabins. Cabin staff must then be available too. Look up cabins with students being allocated to, print out a list of students, and yeah, so what happens here, there's the camp staff, they're the only people that interact with this. You then have the campsite database, and then there's probably 4 different processes here. So you can develop and needs to be allocating groups to different cabins, because there might be groups of 2 that need to be merged together. So that's actually a process. So the first step is you want to allocate the groups. You then want to be able to look up the cabin in which the student's been allocated. You then want to print out lists for the students showing their name and the group name of the group. And then also you want to look at which group the students are currently in, because they might be merged all together. So campsite is the main thing. Those are the 4 different processes when I'm reading through this. Notice I'm just sort of writing out some more information, trying to get my head around here. So in this case here, the students are in small groups when they start, and then they can be allocated into bigger groups, which is what happens here. So to start, the first one here, I would be saying allocating the groups. So trying to give the students the different groups that they can go into. The next step here, the next process, is to look up the cabin where the student's been allocated. So you want to find where the student has been allocated to. So notice that I've done the actors first, the databases, and then now I'm trying to work out the processes and how they're sort of connected in between. So then you want to be able to look up the cabins. You then want to be able to print out the lists. And the last bit is you then want to look up which group the student is in. Now, because we're doing a data flow diagram, we want to work out what the campsite person has to put in and what the output is that they have to do when they come back. So when we're dealing with this, the campsite staff have certain features that they know that they want to happen. So they would put in the student infos in the group choice that they've put in, and then that would go into the database. So the student and that group choice would then go through and just shows you the flow of where they go. So that probably should be student info, sorry, there, not just student. So it should be the student info, and then the group choice goes into that cabin. The student, if we want to look up the cabin, we would put in the student, and then the student would go into the database, and then back should come the cabin that they were chosen, and then the cabin should come back to the staff. So there would be a request that goes into there, and then group. Yeah, cool. So the student and the group goes into that database there, and then back comes here the cabin that they chose. From the campsite, we want to then print out the cabin list. So when we're printing out the cabin list, we're going to have the data coming back to that print list, which is a list of all the student details. So whoever's inside that cabin can come back. And the cabin list comes back as in some sort of format. And the request this way would be probably who's in this particular cabin. So your list has been requested. You could also write down here list request coming through. Sometimes it's implicit though. So then from here, you want to go through, same thing again, you want to have the student, so you're trying to find the student that was in the group, and then the information that comes back from the camp database is the group, which then comes back up as the group. And again, you don't necessarily, because it would become too tedious sometimes to write every small detail. Usually if there's more than two, that's when you would write exactly what information has to go into the database. Right, describe the Agile method. So Agile manifesto, like I've said in the class, probably 8 or 9 times out of 10, the answer is always going to be Agile for project management. So Agile is when you're building a program that's not really defined. So it does work with structured ones, but structured approach is a lot better if it's like a payroll system that you've done for 20 years and you know exactly how to do it. But if there's a level of uncertainty or it's a newer area, Agile is vastly superior, because what happens is you work along with the end user, and at the end you've got a product that they've been working with you and they've got a bit more buy-in. So the Agile manifesto was written relatively recent, so I think it's like 2010, I think off the top of my head. And inside that's got 12 points of what needs to happen when you make something that's Agile. So it's a lot faster as well. So when there's a level of uncertainty, if you want to get a product out to market really quick, it's kind of like freemium games that you've seen out there where it's free to play, and then all of a sudden they might add in features afterwards. So something like Fortnite probably was developed using an Agile approach. So you quickly get it out to market, and then your beta is almost going through that process, working with that end user to try and work out the requirements. And the requirements can change. So as you're having those conversations with the customer, you can adapt and change the way that the product looks, so that when they get their final version of the product, the app, or whatever it is, it's more in line with what their needs are as they were building it. So structured approach is really good if you know very clearly at the end this is what it needs to be. Whereas Agile is if it's a bit hazy and you're not quite sure, it's kind of like walking in a forest and you're not exactly sure which way to go. It's better to be working alongside with the client so that they've got a very clear understanding of what you're trying to build. So if they change any of the specifications, it allows you to do it. And because you're developing with the clients, if there's a really good relationship between the developer and the client, it just makes that product that much better. The other thing that they do is they do sprints. So at the beginning of each week or a 2-week phase, they might come together with a scrum master. So they all come together in a group, and then that scrum master allocates all the different roles or tasks that need to be done in that 2-week sprint or 2-week time frame. And then the group will go off and execute that bit. And then they come together at the end just to review it. And there's this nice incremental process or a cycle that constantly happens, rather than the structured approach, which goes all the way through. So if it's suitable at the end, it's a lot better for big teams and also big projects as well, the Agile approach, because you've got very clear accountability and governance within the structure of the organization, because each of those Scrum Masters would report to their boss above them. And then their boss above them has to try and work out how to allocate the roles appropriately, which can be quite tricky sometimes, particularly for larger projects. And And then yeah, by getting that market quickly gain that product out to market, you'll get a better product, and also the the end user also gets access to it as well if you do the agile approach in full, which is your best person to get feedback from, because they can allow some quick changes, and also it gives a bit more flexibility. Right, railroad diagram. So this first one, you've got an item. So item would start at the beginning. You would then go equals. Now, because it's in a rectangle, you put the parentheses, the less than greater than symbols around it, because it's non-terminating. And then you can have as many digits or letters as you want. So you would then do the curly brackets, and then you could put an or you could put two sets of curly brackets. It does. Oh, no, you need to do one or the other because it has a pathway there. So you can either go this way or you can go this way, and then have as many as you want. Whereas the list, you can then have a shopping list. So that's a terminated value, because see how it's got the circle, so it doesn't use the less than and greater than symbols around it. And then this pathway down here, it's not wrapping back around, so it's optional. So we put a square bracket. You can then have an item, and then you can have a curly bracket, and then a semicolon, and then as many items as you want. And then the items in square brackets, less than and greater than symbols. And then you have to have an exclamation mark at the end. So if it doesn't have the exclamation mark, it's not a valid list. And then items is these things up the top here. So public domain and freeware. So public domain is sort of a copyright issue. So what you're considering there is, once it goes into the public domain, who has the legal rights to it? That's the question here. Now, because we're comparing and contrasting, we really need to define, first of all, what public domain does, and then we need to describe what the difference is between that and the freeware. That's sort of the trick here. So there's three things at play here. You want to define what public domain does, you want to define what freeware does, and then when you're writing this response, you want to make sure that you're contrasting and showing the difference between the two of them. Okay. So public domain means software is free to the people to use. So this is not just the application. It also might also be the source code. So the actual code you can come in and play around with. So something like Linux, the operating system, has a public domain availability where people can get the source code, they can get the full version of the operating system, and they can do whatever they need to do with it. Now, when you're dealing with public domain, there is some sort of trickiness with that. So if the public domain is just for the application, that's fine. But if they haven't listed the source code, it can be frustrating, right? Because the source code might not necessarily be available to the public. Okay, so there are different sort of shades of public domain. And then in Australia, if you do generate and release any bit of source code, it's actually covered. So straight away, it's covered by copyright unless you explicitly say that it is in the public domain. Okay, so the person that has created the product needs to say that this is available for anyone to use in the public domain. Otherwise, it's automatically assumed copyright protecting it. So let's just protect programmers so that they don't get in trouble down the line, and then they all of a sudden go, oh, hang on, no, that wasn't meant to be available for anyone. They can't just edit and change it and modify it. It needs to be explicitly stated to the public so that it can become the public domain. Freeware is a little bit trickier. It's basically free software. So what happens with this software when it's built, it allows people to use it. So Fortnite's a brilliant example of that. So it's free to use, but then it's kind of not. So it's got that store built into it. So it's free to download all the content of it. But what happens with something like Fortnite when it's kind of freeware, it's not quite. But I'm trying to give you a context that might work. So it's free to distribute this software and free to use. But at the end of the day, it's going to have a level of copyright attached to it. So for example, Fortnite, you can't just jump in and then change all the characters around, change the maps, do anything that you want with it, because it does have that protection to the company. and you can't just get in and access the source code and modify it. So for example, you can't get bots and hack it. So that's what the copyright there does. Cool, that's done and dusted. So hopefully that's picked up a bit on the source code. You've worked out exactly how to do the pseudocode. There's a few other bits in there. There was unfortunately 2 things that I didn't do quite right in that. I was a bit late when I was recording it, so apologize. Have a look. I've put a link down below for the actual hard copy of this. So if you want to have a read through it with me as I'm doing it. My biggest recommendation though is to make sure that you've had a go at this code. Have a go at this exam before you watch these videos, because it's going to give you that much more of an edge. So then you're going to be asking questions and seeing how I think it through. Awesome. So thanks again. See you next time on Steam It with Steve. Adios.